Welcome back to Wickerson Studios. I am continuing with this single variable calculus, and things are getting a little more interesting. I'm starting to bring in a little bit of geometries and check it for surfaces and see what's happening within it. It's all being handled through curves and equations, and I'll just show you what's basically happening here. We'll get back to this kind of form later, but let's just go to top view and zoom on in and show you that basically what I've written is creating circles and estimating circumferences. And you'll see why it's actually estimating, because it's not a perfection when you break this down as to what you're actually making. And your mind starts to get into this. You start to creatively say, okay, what's going on? So I basically want to graph x plus y squared, x squared plus y squared equaling some coefficient. I chose the coefficient 0, 1, 4, 9 for obvious reasons. Those can be square rooted. And the data works out pretty fine there. So I can choose a list item and get 1, which is very nice because it actually calculates an estimation to tau, which is 2 pi, which makes a lot of sense if you consider a circle at 1 radii. At 2, at 4, at the square root of 9, the square root of 16. It keeps going. You get these wonderful circumference in what you're doing. And I'm just going to keep that low at 1. And it's not so important that I can move this around because I want to maintain the circle, but you'll see how I've done it. I've actually used the square root function that's written in. You can follow it through positive and negative. You have to keep in mind that I want to create a domain and I want to be able to build this and put it through the function y equals. Well, what would one of these mean? What would that actually mean if I was to solve for y? If I was to solve for y, solve for y? Well, actually, you have to think about that. If I'm solving for y, I can take the square root of that coefficient minus, all in parentheses, x squared. But the problem with that is I don't get the plus or minus. You'll remember writing your equations out as you solve them for one of the variables, you always have to have that plus minus symbol. So I've actually had to produce the points that were above, which is pretty simple, and the points that were below. So if I take this to preview on, those are the points above, and you'll see how they kind of average into this weird thing here and stretch. I think that really gives you a sense of what's going on. And also, outside of that, you can also come in here and you can take a look at the bottom group. So preview on the bottom group. And of course, that's tied to the amount of points that you're generating on those to end up getting this finesse. So as you bring that down, say to 1, you start to really funk out your circle and do some crazy geometries with that. And you can also see the tangents fighting to end facing opposite directions. So you get a sense of imperfection and estimation of what you're actually calculating. So then I throw it into a curve, and I prefer to have these two off because I don't want to see a bunch of points. I hate the grouping tool, but you have to leave everything. Once I get those points, I have a set of curves here, but they share coincident points here. So I've got to use the join curve node. So you start to solve things. You start to think about, well, what would I have to do within another programming language if I had to solve it visually with Grasshopper? The list length can be generated, and you'll see that's very close to 2 pi. So that's kind of nice to see. And then all I've done is made these little points on curved lines that I can actually move my data if it's in the way. I can actually have a little bit of control to get things out of the way. We're creating circles. We're solving for the point at x, y. And so you get a sense of what's being generated there. And then I've also put some words in. I've done a little bit of funkiness with the concatenation and these tools as well. And when I select all those, I'll just select here for now. You see, get some really nice blue lines. But what is going on down here? Why is it red? Well, I've simply taken the area underneath that curve, which is technically the area contained within a circle. And funny enough, the area itself comes awfully close to a number that we've seen before. And there it is. I think that's very interesting to take that and start to see what is the power of this. Now, we haven't gotten into differentiation and integration yet, but all of this analysis to find out what's going on, I think is very important to understanding what you're doing. So I'm using all my visualization tools over here that kind of stand out from my original graph, which is still this original system of actually generating the graph that I'm working from. Now, what's happening down here? This is where it gets a little funky and interesting. Let's take all this and turn this to an able. Maybe I didn't want to turn it all to an able, but I certainly want to turn preview on. Now you start to see some funk. Now you start to see some strange things. Like, what have I done? I brought in all these points that run along here, and I've deconstructed them. And I've done this strange things with these numbers because I have 202 pieces of data coming into X, 202 pieces of data coming into Y. I wanted to play with the height. I wanted to move it around. I wanted to play in the 3 dimensions. So I actually grabbed the range heights and I did a whole bunch of intermixing between X, Y, and Z, Y, Z, and X, and X, Y, and Z again, changing the data up and pairing them. And so this is really, where my mind starts to go as I produce these curves, because they're not so appreciating what's happening here, lofting, or seeing here, but you're realizing when you get a hold of the math and you start thinking about it, what I'm actually generating is this very interesting curve. And what I did here, a little subtlety, is I went in here and I said, I don't want to grab the negative of this. I don't want to have, or what did I want to do? I don't want to end up using the joint curves. I want to go before that with the points, because I produced this very interesting interpolated curves, this one and this one. If you run those through each other, they actually run up through the middle. And you get a sense of that over here on these number lines as you generate one of these curves. And as you start to loft it in the z direction, it gets pretty interesting. So let's grab one of these and just take the control points off and go to the interpolated curve there. And you'll see what's happening. It's actually going across here, counting, and then coming down here and counting here. So it's a pretty interesting curve. It comes like this, and actually that's what happens when you don't go up here and use the join curves tool. You actually get more points and you get a longer curve, which doesn't work out to 2 pi. So you're starting to analyze this. Now, as soon as I saw that nice pattern like that, I thought, well, let's throw that into z. Let's throw that into some numbers so we can actually draw that up and down. So let's just take those two previews off of the lofting, and let's think about it. We're grabbing this one, this curve here, very nice curve, grabbing the opposite direction curve here. Well, actually, that one's pretty interesting. It stays fairly straight. And then the opposite one, this one. So I've got 1, 2, and 3 curves. And that's just playing with intermixing these vertices into what I'm doing. So I think what I've ended up doing is bringing in enough data to have 202 points paired with a list of 202 points. And then you're ending up doing these wonderful lofts. And this is a strange, twisted, kind of ribbon-like form. So is this one. And they end up generating what I think, if you start playing with, if we think about this, we start going back here, we not only can play with this number to make it larger and smaller, which stays relative to size 0, 1, and just playing with different square roots. We can actually get in here and start playing with the finesse of what's actually there. And of course, nothing really happens, but it starts to flatten out. We start to have this kind of ribboning tool down to 1, down to 2, 3, 4. So it's a little subtleties of what's happening in our surface analysis. So I knew I couldn't keep my head on straight and just stay to what I was doing, and I could and just stay out of the all the fun things that are happening on the 2D plane. But you're starting to generate things like these points, and without the z, let me just take off the z here. You'll see exactly what I'm doing. This one, and we'll take off the z here, and we'll take off the z here. You'll see that we're starting to generate different points in different situations that actually produce 3 different curves. These two are awfully similar, but I think it's very nice to think about how that's fabricated through this set of points and how it's actually following. And it has to run through the center here. So just playing off of it, having a little bit of fun with it. We'll take that z and put it in there. I think that was the z component that I put in there. That was the z, and that was the z, and that allowed us to get into these 3 different shapes. I probably fudged this one up a little bit in what I was doing, and I'll end up with a couple of different lofts. And that one's starting to get a little funky in there. You see I've flattened that one. It's not so exciting. Probably want to grab different data in the z in this direction. There you go. End up with a cool little piece of geometry. And this is where you keep things in order by your grafting and finding out what you want to do as you bring this one around. That one's the same data. That one's the same. I'm not sure what will happen here. It'll default. Yeah, to just a little curve that flattens at the top because I'm using 105, I believe 101 points now. Sorry, I think I'm entering in to the z. I think I'm only bringing in 101, 102, 202 coming in, 202. I think this one's down to 101 because I pulled it from back here. Didn't pull it from both the lines. This is about pairing them up. So if you took a single set of lines, took a single set of z, you get this other pattern. And this is where you start building geometry from points. There's no reason not to think about that. So now these geometries over here, this curve, and this curve are different. So obviously our lofts are going to be different as we preview those on and have a look at what's being made. This one doesn't loft, that one does. And that's how you use your data to start driving different geometries. I didn't mean to complicate it with all this stuff. I probably shouldn't be having this playful Wickerson Studio geometries, which really I just want you to go around and play with. It is about staying with these kind of things and thinking about what is happening in the maths, how things are generating, how you're getting estimated things. But I just wanted to make it a little more interesting than here, which is where we started, because the circle itself is not as playful as I go through these square roots, these kind of even squares. Because if you start to do-si-do into an area in between those square roots because of the equation, and let's say we go to rational numbers on that, and I start to move this, you'll see it starts to, well, it still works, but actually I did that wrong. Sorry, I did this before wrong like that. Let me snap that back to the integer one. What we're basically saying is here's our values here that can go from 1 to 100. Let's double click and put on a number slider, 1 to 100, and put that into this value and put that into this value. Now as I generate and roll through, you'll see that's too big, but as it comes down on a number slider here, let's rein that in by, because we were picking number sliders, let's bring it down to 10. Just bear with me a minute. Let's put it to integers. And now we've got this, the number we're playing off. You'll see that it starts to do-si-do and do some strange things. You see they don't meet up unless they hit certain numbers. They actually touch each other and become coincidence. So you don't get that area and start fudging the numbers in these two lines stay separate or stay together. So you're not always making a circle as you go through here at every point. So that's why I chose to put the value of this and the value of this into square roots that are functioning very nicely, and I could just number slide through those even squares. And then it allows me to just see a little more and have some data, have some more control over my geometries. Things get pretty funky when you start getting into trig and you start getting into some really playful things, but I thought this is enough to give you a sense of where I want to go with this. Pretty chaotic video, I understand that. It's 12 minutes. These scripts I'm not actually building for you. Well, I'm building for you. I'm not building alongside you, but they are building out of this entire kind of compilation of scripts that I'm thinking about as single variable calculus. And as I get into it, it does get a little dry. We'll go through some basic parabolas and things like that, but I'll try and do something geometrically fun with it in 3 dimensions as we go. So yeah, the file's getting pretty big. It's pretty nice. It's in its 11th version, or soon to be 11th version, coordinates and graphs. And we'll just keep generating this wonderful script for my GitHub for those that are interested in looking at it. Thanks very much for supporters on Patreon, and happy days.